Welcome back, friends. Thanks for joining me again. Sorry, it's been a while. The holiday weekend sort of got me a little behind on my talks. I was hoping to have one out a little sooner. Um, I wanted to set the stage for some really important information that's been coming out lately about the new viral um, data. But before we go there, you have to understand what is a virus. And trying to set this up, I'm going to have compare and contrast what a bacteria is versus a virus. And sometimes that helps us get a sense of really why this is such a difficult situation and what it really is going to mean for us to get out of this mess. So let's start off with a bacteria. So bacteria, first of all, bacteria is alive. And that sounds crazy to say, but bacteria is a living creature. And bacteria, by that I mean that once bacteria gets in our body, for example, if we get a meningitis and you get bacteria in your brain, the bacteria will replicate and make more bacteria. So it's going to actually grow and replicate on its own because it's alive. And back historically, uncontrolled infections killed a lot of people. And in the 20th century medicine, an antibiotic came along, and that actually changed the course of history, and at least the medical history, and that we were able to control a lot of these really dangerous infections that were killing a lot of people. And so back in the 20th century, this germ theory came alive, and all of a sudden we looked at bacteria as being something bad. And you know, when we had a bacterial infection, we needed to kill it. And the way we did that was with an antibiotic. Because a bacteria is living, when we give a patient an antibiotic, the antibiotic will actually go and kill the bacteria directly. It'll go and kill that bacteria directly, and then it's a great thing. We save lives, and it was a great triumph in the 20th century medicine. But lo and behold, as time passed, we started to realize that got us into trouble. First of all, in our 21st century, we realized, number one, that not all bacteria are bad. And we found that there are actually trillions of bacteria that live on our skin, live in our bodies, and live in every part of our body. Trillions. I wanted that to sink in because that's actually more than the cells that we have in our body. So there's more bacteria in our body than we have human cells. And so if that's the case, we realized in addition that most of the bacteria is good and beneficial for us. And that was in the 21st century. Now, in this day and age, we have come up, or at least realized, that there's something that we call a microbiome. And a microbiome is a collection of all these bacteria, all this beneficial bacteria that live in our body, live in our gut, and especially in our skin as well. And so we realized with this microbiome of bacteria that this congregation of bacteria actually benefits us in that it makes specific vitamins, it makes specific hormones, it helps detoxify our bodies of bad things. So it does a lot of good. And if we didn't have this bacteria, we wouldn't live very long. And so it sort of changed our perspective of what a bacteria is, or what bacteria are. They're beneficial. And so instead of thinking bacteria as being bad and causing infections, that we had to kill them, now we realize that it's really important for us to think of bacteria in the form of balance. And so now, especially in the functional world, we're always trying to focus on getting some balance, and especially with the bacteria. We want there to be a balance of good bacteria versus the not so good bacteria. When it comes to our current situation, with our current health crises and dealing with complex virus, bacteria are very important. They're actually part of our defense mechanism. And so another aspect of being beneficial are the bacteria actually protects us from viruses. How do they do that? Well, let's review what I've talked about before. If we have this cell layer that's in our nasal passage, we have this good mucosa layer that sits on top of the cell, and it's in this mucosa layer that bacteria sit. This is all the good bacteria. And then I tried to convince you that we need this good mucus layer to shelter this bacteria. This bacteria in turn is going to talk to our immune system. And there is a specific immune cell called a T regulator cell. It's part of our innate immune system. And this is the T regulator cell that's the boss. It's the muscle of our immune system. And it takes information from both the bacteria and all these other peptides that sit in this mucus layer that help defend us. And so if there's any concern coming, some concern for an invasion, that information comes to the T regulator cell, and that T regulator gathers all the troops and basically tries to protect us. It starts setting up this barrier so it can hold its ground for any type of invasion. And so the bacteria helps us in two ways. If we have a large amount of good bacteria, it actually acts like a defensive line in a football team. Because there's so many, they actually crowd and physically crowd out any type of intrusion that's coming through. So if you have a specific virus that's trying to make its way through, it has a hard time because there's bacteria that are holding it and pushing it away. As I mentioned, there's probably going to get a few bacteria finally get through, and then now the T regulatory cells come at it. So there's two ways and two walls that are sort of set up to help protect us from virus intrusions. And so that's how bacteria are involved with protecting us from viruses. So they're not all that bad. So what troubles do we find ourselves in the 21st century? Well, one of the biggest problems that we've found ourselves in now that we're evolving and learning more about bacteria is now, especially since we were so excited about antibiotics, now we have a problem with overuse of antibiotics. And overuse of antibiotics, as you can imagine, decreases our bacteria. And so if you don't have very good bacteria, then you can affect your immune system. So believe it or not, if you take rounds and rounds of antibiotics, it can actually decrease your immune system. So it affects our immune system. The other important issue that we have with overuse of antibiotics is that bacteria are pretty smart. They actually will try and find a way to survive. And so if we keep throwing antibiotics at bacteria over time, they get smart enough and they start learning how to resist the antibiotics we give them. And so resistance is becoming a bigger issue now because we overuse antibiotics. And so that's the story of bacteria. And that's, the story of how we've evolved and how we think about bacteria, and how now, at least in this situation, we really have to think of it in a positive way and think that we actually need good bacteria to help our immune system. So let's compare that to a virus, which is different. And I bring that up because I think if we don't understand this, we think that taking care of this virus is a simple thing. Just find a good antiviral medication and we'll be okay. But as you can imagine, it's not so simple. So first of all, let's review viral infections. So viral infections, this is what I talked about before. Same thing. Here's this one single layer cell of our respiratory cells in our nose, for example, or our lungs. If we're in a situation where we don't have very good mucus and we don't have a lot of bacteria, then that, in effect, doesn't help our immune system. So then we don't have a lot of T regulatory cells. And what happens is we have a poor defense mechanism. Now you add to that risk factors. And so you're hearing now that more and more about these risk factors for the COVID virus. And those include diabetes, cardiovascular disease, and now commenting more and more is obesity. These essentially are metabolic diseases. They basically have to do with the relationship of metabolism and inflammation. And I had brought up this concept that when you have a lot of inflammation and now a lot of metabolic problems, you're the one who has a lot of these ACE receptors. And these ACE receptors are actually the doorway for this virus to get into our cells. And so the virus comes in, and that little crown, that little protein spike, unlocks this door on the ACE receptor, and then it drops itself so easily into the epithelial cell, or actually the cell layer in our nasal passage, and then it hijacks our systems. So compared to bacteria, a virus isn't alive. It is not a live organism. And so what a virus technically is, if we look at it, it's a package. It comes with this little enveloped encapsulation, and it has what's called an RNA strand, which essentially is basically it's the recipe to make a virus. And so the virus really is just coming packaged with instructions of how to assemble a virus. And so a virus does not make another virus. A virus has to come into our cells, hijack our smart intellectual DNA, throw the instructions of how to make a virus into our own DNA, and our human DNA makes a virus. So we are actually propagating the virus as a host. And so the virus is not something that can actively and aggressively chase us down to infect us. A virus actually isn't much. It's just this passive package of material that's just cruising in respiratory droplets, just trying to find the perfect opportunity. And that perfect opportunity happens to be this situation where we have somebody who has the risk factors of a metabolic disease, or the risk factors of having poor immune responses. Maybe somebody just took a round of antibiotics and now they don't have very good mucus layer, or maybe they're doing other things that are affecting the mucus layer. And now it's easy for that virus to make its way into our cells and hijack our cells. So that's important, because if it's not alive, then we don't really have an antiviral medication to kill viruses. Because remember I said you have to be alive in order to be killed, like a bacteria. And so when we talk about antiviral medications, which you're talking about a few, I'm not going to name specifics, but there's a few antiviral medications that they're using in this scenario. And with any other antiviral medications that we use in conventional medicine, our goals aren't necessarily to kill virus. The reality is when we use antiviral medications, we're just trying to control replication. So we're trying to come here and slow down our own body from making too much virus. And our goals are to do this, and the reason for that is because if we can do that, then maybe we can catch up to the immune response. So let's go back to this situation where this virus makes its way in, hijacks our DNA, pushes all this viral replication. And specifically for this virus, this is a lot. It will significantly, it basically pushes the gas pedal on replication compared to other viruses. And so it can replicate a lot in a short period of time. So this viral replication is what's now, because we don't have a very good immune defense here, we've already defined that. Now because of that, we end up into a chaos of immune craziness, I'm going to call, because there's, it's a little bit more complex than that, but what it says is we don't have, our response is hyperactive and it's ineffective in taking care of this virus because we don't have the good immune response. We just sort of have a panicky immune response that's not doing the job. And so all this immune crises and immune craziness is what's leading to the problems that we're seeing with these complex infections. And the unfortunate thing is when it comes to viruses, because they hijack our immune system and change the way our immune system responds, then now you can have very complex problems. We're seeing, at least in this particular virus, the complex issues we have with our lungs, collapsing our lungs, we can't breathe, and now we need to be ventilated. The other problems more recently with meningitis, as well as heart issues. And time's going to tell, do these problems become chronic problems? Meaning, if you recover from this particular infection, what downstream problems are you going to have because of this immune crises that we've just gone through? And there's actually now more and more people who have recovered from this infection, recovered in terms of not having severe symptoms, but they're still having nagging sore throats, nagging shortness of breath that just comes and goes. And now we're finding still that there's virus that still persists after a couple weeks, 2-3 weeks, even longer. And so we don't know how this issue is going to pan out. So because it's complex, it's not like a bacteria. We can't just put a silver bullet and take care of the virus. That means it becomes difficult to contain. And that's why we're going to linger with this virus, quite honestly, for a long time. And so when it comes to any type of virus, the treatment goals are, number one, we try and control first. And so they're trying to come up with antivirals to control replication. And the current medications that we have that they're trialing have to do with our immune system responses. And so we're just trying to control this leverage on the virus right now. But down the road, long term, the treatment goal is in containing a virus has to do with immunity. So we have to get immunity to contain a virus. What does that mean? Well, that means we have to either, number one, get an infection, get actively infected with this virus, or number two, get a vaccine. Because if we get an infection and a vaccine and we recover and recuperate, then what these do is they increase our immune response to the virus in a healthy way, because now we've made memory cells that remember, so that it can actually continue to keep this virus dormant and contain it. And unfortunately, what that means when you're talking about what you've heard heard about the talk is herd immunity. So this immunity is herd immunity. So first of all, there's immunity, individual immunity. So if you get the virus, you individually have immunity to this virus. When we want to contain it as a whole, we need multiple people to have immunity against this virus. And right now, the only way we're going to get immunity is really from an active infection, until we're able to come up with a vaccine. And that's the only way we're going to contain this virus. So that being said, we're going to be exposed to this virus for some time, because we can't really contain it until the majority of us, and they do some modeling around this, and it depends on what the infectious rate is, are not values, then they can figure out how many people have to get immune to this. And so sometimes, I don't know, I've heard 70%, some people, say up to 80%. 70% of the population has to have immunity, whether that's an active infection or through vaccination. And so we just have to wait for us to hit that spot before this virus is controlled. And in the meantime, as we're waiting for us to get to that point where we're controlling this virus, we're trying to control the replication, and we're trying to support patients' immune responses. And so that's why it's really complex, and that's why we're in the long haul with this. But I bring this up because in the next couple weeks, they're going to probably, at some point, release the quarantine recommendations. And so we're going to be out there exposed to each other, and we're going to start being exposed to the virus once again. And so then the virus is going to look for those of us who continue to have poor innate support. We don't have, the virus is going to look for the person who doesn't have good mucus layer, the person who doesn't have a good bacterial support, and the person who has some immune dysfunction. And that might be just a young person, who just, has a poor diet. Or it might be these metabolic diseases, which they've come to realize that there's a discrepancy, at least when realizing that Hispanics and African Americans and minority ethnic groups have a higher risk for complicated COVID. And part of that has to do with our risks for metabolic disease. And so that's an interesting idea, to have this metabolic imbalances that are setting us up for viral infections. And that's important to know, because currently in our American USA culture, depending on what literature you read, up to 1 out of 3 of us, 30% to even up to 50% of us, are metabolically challenged. We have issues with prediabetes, we have issues with obesity, and those are risk factors. And so it'll be interesting what time tells, but now that we know this type of information, I bring it to point because really you can change this in a quick time frame. You can literally change your lifestyle and change your diet, and within 3 to 4 weeks, you can change your bacteria. So as you're preparing to be set out to be more exposed to the virus again, you can actually start making changes now to build up that immune response so that you can help protect yourself for the time that we eventually get exposed to this virus. And if we do get exposed to it and we have a good immune response, then we could say at least we can contribute to this herd immunity that we actually need to overcome this virus as a nation and as a world, as humanity has to face the same infection. So I wanted to set that stage because I'm going to start talking more about this aspect in the next couple of days. And I wanted you to appreciate the complexity of the virus, and I wanted you to appreciate that eventually we're going to have to face it. You know, eventually we're going to have to face, you know, either active immunity, because it's going to be a while before we get a vaccine. And being proactive about this is a good step to being healthier. So if you find this useful, pass it on to anybody who you think might benefit from this type of information. You can sign up for my YouTube and get the videos that I post sooner than when I put them in Facebook or any other social media. And or if you're interested in working with me, you know, give me a call, because I'm still taking care of patients during this time through virtual care. But more importantly, I just want you all to understand that you actually have some ability to make some changes now, and see if we can, together as a society, find this herd immunity so we can sort of get back on to living. Thanks for your time, guys.